And you will find that in this experiment, or in the whole open network programmabilities, we only use one device, and this device is the access one. And we will use this device to function as the network device, and then we will use one PC, and this PC is PC1. We will run and write the Python script on the PC1, and before that, you should know that PC1 should have the ability to run the script. So we need to install the Python environment on the PC1. And for the detail about how to install the Python environment on your personal computer, you can just refer the hcip.com Python Programming Basic Lab Guide. In this lab guide, it will teach you how to install your personal Python running experiment environment. And now let's look at the first lab. The first lab, it is the SSH lab. We will use the Permico module and to SSH, use this protocol to log into this device. And then we will use this module to execute some command, and then we will check the result. First, let's look at what is our topology about this lab. We just have one switches, and these switches will create one interface. The interface is VLAN if1, and we will configure its IP address, and after that we will configure the PC its IP address, and that is the environment, and that is the topology. We find it is very simple. And then let's look at the roadmap about this experiment. The first thing is we need to configure the basic configurations on the access1, all right? And then we need to configure the SSH on the access1 so that we can log into the access1 by the protocol of the SSH. So we need to create a SSH user, and we need to generate the public and private key of the PC1. And then we need to upload the key to the access1, and then we need to configure the SSH for the public key login. That is the configurations about how to enable SSH and how to use the public key to log into device. And after that, we need to compile and execute the SSH login script. And after that, we need to just pause the script. And after that, we will configure the SFTP functions for the access1. And then we need to compile the FTP code. And last, it is the execute and interpret the script. Okay, now first let's finish some physical configurations about the access1. Now you can find that the access1 is just reboot after we reboot. And then we need to do some basic config, just follow the lab guide. And then I think we need to configure the PC's IP address to the same subnet of the switch. And then we need to try to test the connectivities between PC and the access switch. And now you can find that the PC can communication with the access switch, and then we need to configure the SSH protocol functions. First, we need to enable the external functions, and we need to configure the SSH source interface to all interfaces so that the access switches can receive the SSH packet from the not managed interface by default. the device, it will only process the SSH packet that is received from the manage interface. So we'll use this command to let the device will process the SSH packet received from all interface. And then we need to configure the VDFI interface. Wait a moment, and I think. And I think I need to configure it by myself. And the first command is we need to enable the extended service, and then we need to configure the interface to all interface. So let's configure it. Then let's configure the VTY interface. After that, we need to configure create a new users, and this user's name will be person, and we will use this user to log into this device. And then we need to set the user service type to the SSH, and of course, we need to configure its password. So just let's enter the AA wheels, and we configure it. And the AA wheels create the users and set its service type to the SSH. And what is next? The next is we need to configure an SSH user and set the authentication mode to the ICK. And then we need to set the service mode to STLNet. And after that, then we will generate a key using the OpenSSH. OpenSSH, you can just find it in all the Linux or the Windows, I mean the mainstream versions. For example, you can find that on your personal Windows time, and you can just use this command to generate the OpenSSH keys. And I will show you how to generate it, but I have already generated one. Just for example, in this, we need to enter the system document. Wait a moment. System, and inside it, and I think I can configure it. All right, and then we can use this command to wait a moment, and then we can use this command to generate the key. Wait a moment. SSH. Wait a moment. You can just find that by using this command, and we can generate a public and a private keys. And I have already generated once, and you can just find that on the path that you specified. And you can find that for me, it is in this page, in this path, the PC1. And wait a moment. And wait a moment, and I've put it in this place. And you can find that I have already generated the case, and the key, it is the IDSA. And you can open it by, you can find that it is the private case. It is a private case. And it is a private case, and also we will have the public case. And you can just use the case that offered in this experiment document, or you can use the command to generate it by yourself. But now you can find that we have already get the public case. But for the switches that we used in this experiment, it cannot recognize this format of the public case. So we need to just convert its format. If you have a Linux host or just a Linux virtual machines, you can use a Linux to just convert its format to this format, and it is not the base 64. It is just the following format. You can just find that, and then we can just use the command to configure it on the device. And we can just try to configure it on your switch. First, we need to configure enter the SSH wheel and use this command. And then we need to enter this command. Public key could begin. It tells the device. Then you will input your public key. And then you just need to input the key that you just convert. And then use this command, public key code end, to tell the device you have already finished the input of the public key. If it is success, I mean, if the device can recognize your public key, it means, and without any errors or any warnings, it means your public keys have already been recognized by the device. And then just use this command, peer public key end. Now you have already finished to create a PRK, and you will find that ISA PRK and SSH is its name. It means you create a public key, and this key, its name is the SSH. And then just to assign this key to specific users, you should know that we need to assign the user person with this key. Okay, now we have already finished our configurations. And what is that? And what is next? Next, we need to log into the device by using the parameter, by using these parameters, and we need to configure the field code. And then just configure our PC once and open our compile environment. And you can find that actually I have already finished this part, but now I will show it again. Just like let's import the field code, and first we can just to run this code. And wait a moment, we will get the result. Document case IDIC. You can find that we have already get a result. You can find that we have already get the input informations. Okay, now just let's look what input information we get. You can find that first, after we use the script to log into the device successful, we we use this command, screen length 0 temporaries, to set the device will output all the display information just at once. And then we use this command, display version, to check the device is version information. And then we execute this command, display memory usage, just to check the device is memory usage. And then we use this command, display CPU history 1 hour, to check the CPU usage in 1 hour. And then just let's look at the script. what we do in the scribe. The first thing is you should know that we use the parameter, use these modules to finish to meet our requirement. So the first thing is we need to import the parameter to import these modules. And besides the parameters, we use another module. Its name is time. It means we can use these modules to control the running time of the scribe. And then when we initial SSH object, we use this scribe parameter SSH client. You should know that we use a class that belongs to parameters, and then we assign the object to instance, and its name is the SSH. And then we use this command. It's the allow unknown host to be connected, just to tell the scribe the host. I mean the in our experiment, it is the access switches just to tell the scribe it is a unknown host, but we can connect to it just to use this SSH set mission host key policy, and it is the auto add policy. It means if this host is an unknown host, we will add it to the policy. And then we need to establish an SSH sessions. It is use this command SSH connection. It means we will build a connection between our scribe and the host. And you need to specify these parameters. It is the host name. You need to tell the scribe what is the domain name or the IP address of the host, and which port to connect it to the target host, and which username used, and what is the public key that we will use. It should be the private case. What private case we will use to log into the device. And just by use these parameters, the our scribe can log into the switches. And then we need to open interactive sessions. Use this scribe. It is the SSH invoke show, and we will find that we will assign it to the instance. We call it the command line. It is CLI. Just we use it, and then we just need to run command lines. The first is we need to send this command screen lines 0 temporaries to cancel the screen splittings, and then check the device version numbers. And then just to let the scribe to have the time to receive the output information from the device, we need to set the sleep time just to tell the scribe you need to stop for 1 second. Time sleep. Use this method. Use these functions to stop the running data of the scribe for 1 minute. And then we just obtain the command output of the channels. We use this method, use this method to receive the output information from the device, and we will set the maximum data that received from the channels, and we set it to the maximum. And then we need to decode the output information that received from the device. And then we need to run another command. It is the display memory usage, and do the same things. We need to tell the scribe you need to stop for 1 second, and then receive the information that sent sent from the switches. And at the last, we do the same things. We run the command display CPU usage history 1 hour, and let the device, let the scribe stop for 1 second, and then receive the output. And now we have already collected the output from the device. And what is next? The next thing is we need to print the result, just to print the. You can find that all the output information we have already assigned to parameters. All right. All the values, and then we just to print them. And after that, we just need to close the scribe. So you can find that is what we do by this scribe, and you can find that you can find that by running this script, we can get information from the switches. And if you have the abilities, you can try to pause the output information. For example, you can check if the CPU usage is have already reached a higher level values, and if the version information, if you need to update your software of your switch. And what is next? The next is we need to use this script to finish the FTP functions, but it is not the normal FTP, it is the SFTP. And the first thing is we need to enable the SFTP function of the switches and to add SFTP use type and configure the survey directory. Just configure it, let's configure it on the device. Now you can find that we have already enabled the SFTP functions of the switches, and we set the user person is server type to all. It means it can be SFTP users, and we set the working directories for these users. And what is next? The next thing is we need to run the script, and we need to just need to run the script. And before we run the script, I need to check if I have already just raised the configurations. Wait a moment. Demo.txt, this is the demos, and config. All right, now let's run the script. And I think it will don't have any output, but you can find that the result, this field I just deleted it, but now it have a new one. Why? It is the result of the script. Okay, now just let's look at what we do by using this script. You can find that the first thing is still we need to import the parameters, and then we need to create the ISA object. All right, and what is next? The next is we use the parameter transport. We use this class to create a transport. And you find that it is not a connection, it is a transport. And then we need to create connections. We need to assign the username, the key, and you can find that the key we have already assigned it by use this script, all right? And we tell the path of the key. And what's next? The next is we establish SFTP channels, use this script, parameter SFTP client from transport. And then what is next? The next is we need to set the local and remote path for uploading and downloading. You can find that we specified the local path. I mean the upload local path. We specified which file we will upload, and we have already specified the remote path. It means in which path we will put this file on our switches. And then we specified the local path of the downloading. It means after we download the file, which path and which name we will store the file on your personal PC. And the remote path, it means which file, which path you will download on the device. And then we have the values. And what is next? The next is we just need to run functions. We run the get and put functions. You need to tell the get these functions what is the path on the remote device and what is the path on the local device. And for the port, it is same. What is the local path and what is the remote path? And then if you run this command, for example, for the get, you can find that. For the get, its local path is this. It means after we download the file from the service, and we will store in this path and by use this name. And what is the remote path? It means which file we will download from the service. You can find that we specified its path. You can find that it is the VRP config zip. What it means? It means the running config file about the access switch, all right? And for the port, you can find that what is this meaning of these functions. You can find that it means we will put this file. It is just a demo.txt, all right? And we will put it into the remote path. And you can find that now on, and actually you can see the log information, and it have already shows our operations, all right? You can find that it is the operation request from the client, and it is the survey initialization, and then we just try to download the files, and you can find that for this it is upload. We can just check the result. If on this device we can find a new file, it should be this. By using the dir command, you can check all the files that exist on our device. You can find that we should have a demo.txt, all right? And you can find its time. It is just today. Just upload maybe just upload in 10 minutes before. Oh, no, it is just 6 minutes before. And you can check its content. And you can find that its content just one sentence is a demos, and it is the same by the file that exists on my personal PC. You can find that it is the same. So now we just use our script to finish this file input and upload. And what is more, you can just try to imagine it. We can use this script to upload the software to the switches, and then we can use the script to let the switch to just install the software and report specific times, and then we finish the upgrade about the switch. All right. And what is next? You can find that if you have a lot of devices that need to be uploaded, and you need to upgrade the software versions, you can just use this script, just use these modules, and just click the running, and all the things will be finished, and you don't need to log in the device, and you don't need to upload the software by yourself. That is why we use the Python script to do our daily meetings. Okay, that is the first experiment, and if you have any questions, you can type it.